problems are AP style problems where we need to be able to differentiate notation. Here we've been given the graph of f prime. So this graph represents a derivative function. Now it doesn't tell us what's happening at f on the graph of f, but we do, although it doesn't tell us exactly what's happening on f, it does give us an idea of what's happening on f. So for example, here is a slope of 0, so here we know that it's stationary. It's kind of going up. Something's happening there. It looks like there's probably an inflection there, and then it's kind of still going up. The f graph is still going up because the function is positive, the slope is positive, and then it looks like it's going to top out here, and then going to start going down. Okay, because of the y values are negative. Now, so it's really hard to interpret. We're going to have to get good at doing this, but the basic idea is we don't know exactly what's happening on the graph of f when we're given just f prime. So we need some information on f to do some of this problem. But we've been given some composite functions, or some functions here, which are made up of parts of f. So here's f times x squared gives me the function g. If I take the function f, and again this is not f but f prime, but so that the undifferentiated form of f here divided by x will give me h. And here we've been given some information about f. So f of 2 equals 1. So this is some information about the value, the y values on the actual graph of f, not f prime. So how do we do these problems? So I need to generate the slope of not the f function but the g function. But the slope of the g function does have something to do with f, and I can find that out by differentiating this notation. So g prime of x is going to be f prime times x squared plus, since it's product, f of x times 2x. So there's my derivative g prime. If I want to find the value of g prime at x equals 2, well, I need to know the slope at x equals 2. Well, I know x. I also need to know the f value at x equals 2. So this is the one that's a bit of a problem because we don't really have very much information about x. And then times 2 times x is 2. So we don't have the y value at x. We know what x is, but we don't have the y value of x. Okay? But the nice thing is that y value at x equals 2 happens to be the one given. Okay, we kind of lucked out. We didn't really luck out. This question was designed that way. So we end up with g prime of 2. To find out f prime of 2, I actually go to the f prime graph, and f prime of 2 is equal to 1. So it's going to be that blue point right here. That's f prime of 2. So that's equal to 1. So I'm just going to fill that in. Times 2 squared. Well, that's going to be 4. Plus f of 2 is equal to 1. And we got that from this value here. And then times 4. We have everything that we need to calculate this, so we end up with g prime of 2, or the slope of this g function, which is based on this f function. The slope of that function works out to be 8 at x equals 2. So we've differentiated the notation, so this is what we're going to do for this one here as well. So h prime of 2, we need to find h prime of x first. We're going to differentiate the notation. This is a quotient, so we need to apply quotient rule. So f prime, the derivative of the top times the bottom, minus the function times the derivative of the bottom, which happens to be 1, all divided by x squared. So if I want to know h prime of 2, I need to know f prime at 2. I know the x value. I need to know the f of value at 2, and I'm going to divide by 2 squared. So this is the same as the problem before. I have f prime of 2. Yeah, I can fill that in. So that's going to be 1 times 2 minus the f of 2 is going to be the value of 1 times 1. So that first one is that function that was defined up here and divided by 2 squared. Okay, and then we can plug that in. 2 minus 1 is 1 over 2 squared is 4. So the slope is equal to 1 over 4.